Here we have two rotary units, one horizontal and one vertical, and they are synchronized to communicate with the robot. In order to gain more space, we can move this unit here under the robot. Robot allows movement in 6 axes and taking into account the 2 additional external axes. By rotating units, we can shot peen virtually every workpiece. For the purpose of peening the inside of the pipe, we have developed a rotary lens with its own drive for internal blasting, which is simply mounted on the robot. As you can see, the entire chamber is protected with 5mm rubber for a longer lifetime. Also, the robot has its own rubber protection to protect them of direct beam of blasting medium. Cascade cleaners from the side take care of dust extraction from the chamber. Here we have 2 filters. One is for the dust extraction, as I mentioned, and the other one is for pneumatic transport of blasting media into the recycling system. Specialty of this cell is also filtration system, because you can very easily switch between metal and non-metal blasting media on PLC. Blasting media is extracted from the cell through the piping into inertia cyclone, where it's separated from the air. Material flows through this rotary valve and magnetic separator into these vibrating sieves. And it goes through this hatch where you can choose either it's metal or non-metal material. The main difference here is at the bottom of the pressure vessel, where we can find the magnavalve, which is very accurate to control. Magnavalves are precisely calibrated for the specific blasting media, such as glass beads, ceramic beads, steel shot or cut wire. When we write the recipe in the PLC, we choose the blasting media and define the media amount. With this kind of application, we can achieve extremely accurate, reproducible and traceable process of shot peening.